Okay, kids, so in this video I want to explain to you how these two expressions that you see here, this one and this one, can be used and where or when you have to use them. So for example, imagine that you have a group of things. Maybe let's say that we have a group of 7 things, but let's actually make it better. Let's say we have a group of 7 students, but from those 7 students I want to make groups of 3. Of 3 students. In how many different ways can I form those groups? Okay, so it depends if the order matters or not for using any of these formulas. So if I want to know how many groups of 3 peoples can I form, taking into account the order, so that means that if I, for example, form a group of, I don't know, Wilches, Gaitan, sorry, with capital, and Samuel. Okay, if the order matters, this is going to be different than Gaitan, Muel, and Wilches. Okay, these are two different possibilities because even though they are the same people, the order is different. So if I want to take into account the order, I should use the first formula, okay, the formula of permutations. Okay, but if I don't care about the order, so for me it's the same having Wilches, Gaitan, and Samuel, or then Gaitan, Samuel, and Wilches, then I have to use the second formula, which is the formula for combinations. In this case, we get the amount of different groups that we can have, not taking into account the order. So, as I said, this is going to be the same than this, because they are the same people, even though the order is different. So it depends. So let's first do, for this case, 7 students, but I want a group of 3. Let's do the first one. Let's do the permutations. In this case, the order does matter. Okay? So what is N and what is R? The P just stands for permutation. ¿Listo? While the C stands for combination. Okay, so in permutation the order matters. In combination, order doesn't matter. Okay, so let's do the permutation for this. So N is going to be the number of elements or students in this case that we want. In this case we are going to have N. Okay, and R is going to be the number of elements that I want the groups to have. So this one is going to be R. Okay, N is 7, R is 3. So we are going to do this part. N factorial, what is N? 7. So 7, 7 factorial divided by, inside parentheses, N minus R. So N is 7 minus R is 3. Okay, and factorial outside the parentheses. So that means that we are going to have to do first the parentheses. So let's do it. This is 7 factorial, and then first the parentheses, 7 minus 3 is 4, and the factorial is outside. ¿Listo? So 7 factorial over 4 factorial. Right. We can do it right now with calculator, but if you don't have calculator, I want to show you a trick that I have. So let's write this as it is in multiplication. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And let's write the 4 factorial. 4 times 3 times 2 times 1. If we look closely, there are equal things here and here. Look, the 4 with the 4, the 3 with the 3, the 2 with the 2, and the 1 with the 1. So if we can have equal things up or down in this expression, we can get rid of them. We can eliminate them. And the only thing that is remaining is just the 7 times 6 times 5, which we can do right now in the calculator. 7 times 6 times 5. Okay, the answer is 210. So we can make 210 different groups out of 7 students. Okay, groups of 3 out of 7 students, taking into account the order. Okay, now if we want to do it without considering the order, okay, without considering the order, we have to do a combination, which is similar, is almost the same. The only difference is that we include this r factorial. Okay, so let's do it once again. Let's do the combination this time. So n factorial, in this case, n factorial is 7. 7 factorial. Over n minus 3. 7 minus 3. Okay, because, sorry, n minus r, which is n minus r, 7 minus 3. Factorial. Okay, and then there's nothing, so that's a multiplication. R factorial, and r is 3. 3 factorial. Okay, once again, let's do this, and first the parentheses. 7 factorial, 7 minus 3 is 4, 4 factorial times 3 factorial. Okay, and what is that? Let's expand it. 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial. 4 times 3 times 2 times 1 times 3 factorial. 3 times 1, sorry, times 2, let me do it right, times 1. Okay, and once again we can do the same that we did before, sorry. So 4 with 4, 3 with 3, 2 with 2, 1 with 1, and that's it. So we can get rid of this. Look, now we have up only the 7 times 6 times 5, and down the 3 times 2 times 1. Okay, because we got rid of all of this. This is gone and this is gone. So what is that? 7 times 6 times 5. Let's do it once again. I forgot the result. 210. Yes, that was it. Okay, and now this one, 3 times 2 times 1. 3 times 2 is 6. 6 times 2 is 1. Sorry, 6 times 1. Ay Dios. 3 times 2 is 6. 6 times 1 is 6. And finally, it is 210 divided by 6. Let's do it. Okay, it is 35. Sorry, 35. Okay, so we can make 35 different groups of 3 people out of 7 without taking into account the order. Okay, and kids, one last thing. This is really, really, really important. If in a combination or a permutation you get a decimal result, That's wrong. In this type of problems, you can only get natural numbers.